Okay, so we're going to start off with bell work. Oh, hang on. All right, so we're going to start off with journal 33 here. And in this bell work, you are simplifying the expression. So like this one, we can see where it looks like a fraction, but fractions just imply division. And so we're dividing all of this with all of this. So I want you to concentrate on what are the like terms. Like this 4 and 8 are both numbers, so you can divide them. So if we think about it, 4 over 8 can be reduced as 1 over 2, because 4 goes into 1, 4 goes into 4 one time, and 4 goes into 8 two times. So this is really 1 over 2. And then if we look at the x's, they both have the same base. They have different exponents. So when you're dividing x's, or when you're dividing something that has the same base, you subtract the exponents. So 4 minus 3 gives you x to the first power. And then this y here is a 1, so if you divide the y's, you're going to subtract the exponent, so 3 minus 1, y to the second power. And that there is your simplified expression because you can no longer combine any like terms. On this one here, I want you guys to recognize that there is a negative exponent. So if we have a negative exponent, that's when you need to make a fraction, because in order to change this negative 1 into a positive number, you put it in the denominator to make it a positive 1 exponent. Now, the x squared is not a negative exponent, so it gets to stay in the top. So x squared gets to stay in the numerator. And that's it. I can't combine x's with y's. So this is my final answer because I no longer have a negative exponent. Okay, so let's take a look at our next slide here and into our lesson. So here I want to start us off with just simplifying polynomials. So polynomials just mean many terms. And in this case, this first one you can see here, it's taking this polynomial and dividing it with x times y. So take a look at how many terms you have. You have a 1, 2, 3. 3 terms because it's being separated with a minus sign or a plus sign. So if there are 3 terms on the top, notice how there's only 1 term on the bottom. So if you only have a 1 term in the bottom, you can actually separate them based off the top. So there's 1, 2, 3, so you can separate this 3 times. So what I mean is this 3xy to the third gets a yx, or xy, and then the next one, x squared over x squared y, gets its own xy. And the last one here gets its own xy. So every one of these terms gets a denominator, so you're splitting it up this way. That way you have an easier time simplifying. So you only have to simplify it one at a time. So if we're looking at this first one here, this is a 3 on the top, and on the bottom there's not really a coefficient, but you can assume it's 1, right? So if you divide 3 with 1, you just have a 3. And then if you look at the x's, well, that's x to the first power and that's x to the first power. When you divide them, they're actually going to cancel each other out because they're the same amount of exponents. So you don't have any more x's. That is a y to the third power, and then in this bottom you have y to the first power. And so if you subtract the exponent, 3 minus 1 gives you 2. And so you have y to the second power. And then it looks like the y's cancel out in the second one. So looking at this one here, we have a minus sign. This x here is the first power, so x squared divided by x to the first power, you would just subtract the exponents. So that'd be 2 minus 1, which is x to the first power. And the y's canceled out. By the way, you don't have to write that one. It's a little bit redundant, but I just wrote it anyways. There's a plus sign here, so I'm going to bring that down. Looks like there's just a 2, so 2 is just being divided by 1, so it's just 2. X's cancel. That y is to the first power, so 2 minus 1 when you divide becomes a 1. So looking at this here, you would try to combine like terms, but notice that's a y squared and that's y to the first power, so you can't combine them because they're not the same exponent. So this is your final answer. Let's try this next one. You will notice with this next one, there's a negative 1 here. And so it looks like multiplication, right? This parenthesis looks like it's multiplying to this parenthesis, but if you look at deeperly, this is a negative 1. And we know that when it's a negative 1, as an exponent, we need to make it a positive exponent. So we're going to make a fraction where we'll put the 2ab in the bottom to make this a positive exponent. So now it gets to be a positive 1 exponent in the bottom, but then this piece here is not a negative exponent, so it gets to stay in the top. So from here, you can see that you can split it up into 3 terms, 1, 2, 3, and you're going to be dividing by 2a in each of them. All right, so in this case here, if I'm dividing this first piece, looks like you have a b in the top and a b in the bottom. So in this case, they will cancel. 4 divided by 2 gives you 2. And then the a's here, a squared, and this is a to the first power. So if you subtract those exponents, 2 minus 1 just gives you a to the first power. Then I have a plus sign, I'll bring that down. 2 divided by 2, well, that's just 1, right? Or they'll cancel. Basically, everything here cancels. But if everything cancels, you always have a 1. So keep that in mind. Minus sign drops down. 8 divided by 2 gives me a 4. A's cancel. And then b is going to be to the, well, 2 minus 1 gives you b to the first power. So in this case, this is my final answer because I can't combine any more terms. So I hope you guys can see that the theme of today is the idea of dividing. How do you divide polynomials? And so before I get into the really deep part of how do you divide polynomials, I want to get you guys thinking about just division in general. So you do not need to write this in your journals. I want you to kind of pay attention and just think for a moment. So back when you haven't learned about division, you have to start using long division is what we call it. And so long division is this box, right? And like inside this box, you take the number that you want to divide, which is 381, but you're dividing it by 2. So 2 goes outside the box. And you start it this way, right? And you're being asked by the teacher usually, like how many 2's goes into 3, the first digit. And well, that's just a 1. And then you would do this multiplication. 2 times 1 is 2. And then you subtract. You always subtract it from what you have. And so then you have 1. And then you bring down all the other numbers. And then from there, you ask yourself, okay, how many times does 2 go into 18? And so in this case, it's 9. And so 9 times 2 is negative 18. And so if you subtract, you get, 0. And then just like a 1, right? So in this case, there's not a digit here, so there's going to be 0 here. And then this 1 is left over. 2 can't go into 1. So this is what we call the remainder. And the remainder is what we always put over what you're dividing, which is 2. So you have, it looks like the answer is 190 and a half. And so this would be your final answer. That's how we did it back then. Now, there's a way you can use long division to help you solve a polynomial. So let's say I was dividing this factor into this polynomial. What I have to do is put this polynomial inside the box. And so that's going to look like x cubed minus 4x squared plus 6x minus 4, and then x minus 2 on the outside. Now, this does take a bit of work and a bit of bookkeeping. So what you have to ask yourself is the first term here is x to the third. What do you need to multiply to x to make it x to the third? Well, that's x squared. And so in that case, when you multiply x squared to x, that's going to give you x cubed. But you have to multiply this x squared also to negative 2 and put it on this side. So that's going to be negative 2x squared. And then when it comes to division, you always subtract. So I'm going to distribute in a negative and now try to subtract. So this will cancel. And then this would become negative 2x squared Then I'm going to bring down the 6x and the minus 4. Oh, my bad. That should not be a... Oh, no, I'm right. So I have a negative 2x squared now. So I'm going to see, what do I need to multiply to this x to make it a negative 2x squared? Well, in that case, I need a negative 2 to make a negative 2 as a coefficient and an x, because x times x gives you x squared. So I multiply negative 2x with x, I get negative 2x squared. And then negative 2x times negative 2 gives me a positive 4x. And then I need to distribute a negative sign because I'm subtracting. So then that's going to cancel. And so if I add these two, I'm going to get positive 2x minus 4. And if I multiply this x minus 2 with 2x, right? So let's think about it. What do I need to multiply to give me 2x? 2. So if I put a plus 2 here, positive 2 times x gives you 2x. 2 times negative 2 gives you negative 4, but then you have to subtract. So then when you subtract, notice how like everything cancels out, like that cancels out, that cancels out. So it looks like your remainder here is just 0. So you don't have anything left over, which tells me that this is your quotient. Like after you divided, you got this as your, from dividing this factor into this polynomial. So you got this expression. All right, so like I said, you don't need to write this in your journal because I know when you guys are listening to me talk about this, this looks pretty heavy, right? It's pretty complex. It's actually not terribly hard, but it's a lot of bookkeeping. So I'm going to show you a type of division that takes care of this without being this strenuous. So that type of division is called synthetic division, and I'm going to show you how to use it. So synthetic division is a really nice technique for dividing polynomials if you have a linear expression. So that means that the x that you're dividing with has to be to the first power, and the leading coefficient needs to be a 1. So this leading coefficient in front of x needs to be a 1. And in this case, I have 3 examples, and let's see which one qualifies for this case. So you can see that with the first one, it's x squared. Well, that's not a linear expression. In fact, that's a quadratic expression, so this doesn't count. Then this one's x to the first power, so that part passes, and the coefficient in front of it is a 1. So this one will work if you want to divide with it. This one is to the first power, however, the coefficient in front is a 3. So in this case, this won't work either. So in order to divide, it needs to look something like this, where x is to the first power and there's no number in front of x. And so it says when you use synthetic, it must be ordered from highest to lowest power, and you see this a lot. And the 0, you have to find the 0 of the linear expression and use the value in your box. And I'll explain what they mean by box later when I show you an example. But a linear expression is talking about like when you're trying to find 0, basically let's pretend this is our linear expression, x minus 8. When it says to find the 0, you have to set it equal to 0 and actually solve for x. So if you set it equal to 0, x is equal to 8. Basically, you're going to take what you're dividing, set it equal to 0, find what that number is for x. All right, let's do some examples here from the homework. All right, so we're going to start off in packet 7, page 3, and I want to start with problem 5, since I want us to use the synthetic problem. The synthetic type of division. So what we're going to be doing is basically taking this polynomial and dividing it with a factor. Now, a factor generally has 2 terms inside. So unlike the problem that we were doing where we're simplifying polynomials, it only had 1 term to divide, where this has 2 terms. And so when you're doing this type of dividing, you have to use synthetic division. So what you do first is you make a box. And inside this box, you're going to look at your linear expression or your factor. So that's x plus 1. And you have to find the 0. So that means you have to set it equal to 0 and solve for x. So that's going to be x equals -1. So I'm going to put in here a -1. Afterwards, I might start to notice that like every time I want to find the 0 of this guy, all I'm doing is switching the sign. So if that's a positive 1, that's going to be a -1. And this happens every time you solve for a 0. And so now I need to look and see what is my highest power. Well, it's x to the 3rd power. So I know I have to write this as x to the 3rd. And then what you have to do is you're going to just write the x's until you reach the constant. So it looks like I have x squared, and then let me spread this out just a little bit more. X squared, and then my x. And then underneath them, I'm going to write the actual coefficients. So it looks like x cubed has a 1 underneath, x to the squared has a -4, x has a 1, and then the constant is -2. So you can see here, all I've done is written an outline, and then the numbers of the coefficient is underneath them. And so I like to do it this way so I can, order them. And then I'm always going to bring the first number down, which is a 1. So you always bring down the first number. Then you take this number, the numbers that are on the bottom gets multiplied to the number in the box. So 1 times -1 gives you -1. And then once you have that number, you put it behind this line, and you always will add the two numbers. So when you add, you get -5. And now this number in the bottom gets multiplied to the box. So -5 times -1 gives me +5. And then when I add these two, I get +6. 6 times -1 gives me -6. And when I add these two, I get -8. And so what this tells me is these numbers represent coefficients for the following. The first one on the right is always your remainder, okay? And then afterwards, it's your constant, and then it's your x to the 1st power, and you're going to keep increasing the power of x until you run out of digits. So in this case, mine only goes up to x squared. So from here, I can write the equation that, the expression after I've divided. So this is going to be 1x squared -5x plus my constant, which is +6. And -8 is my remainder, so you always put the remainder over what you divided, which was x plus 1. So x plus 1 goes in this bottom. And there we go. We have our equation here after we've divided. So we're going to do another one of these just so we get some practice in. So in our next one here, we have like a -1 here as an exponent, right? So just like one of the problems that we saw when we were simplifying. This one here, it looks like it's multiplying this guy with this one, but I want you to notice that negative exponent. Anytime we have a negative exponent, we have to make a fraction, so we can put the thing that's a negative exponent in the denominator. Now, this piece is not a negative exponent, so I'm going to put this on the top. So that's x to the 4th, x to the 3rd, x squared minus 4x plus 4. So what I'm going to be doing next is I need to divide x minus 1 into here. Well, there's two terms here, so you have to use synthetic division. So synthetic division, we're going to start with our box. And basically, you're going to take this x minus 1, and you're going to set it equal to 0 so you can solve for x. So when you do that, notice how x is equal to positive 1. Or if you realize that that's a negative 1, in the box will be a positive 1. Then afterwards, you're going to need your highest power. So in this case, x to the 4th is our highest power. So I need x to the 4th. And then I'm going to keep going until I have reached my constant. By the way, let's say that there was only like, let's say there's only two terms here, okay? Or like, let's say there was only these two terms. Even though if the power is to the 4th power, you still have to write them all out, even if you don't have that power in here. And maybe I'll explain this with a different problem later on. So underneath it, I need the coefficients. So it looks like I have like a 1 underneath, x to the 4th, a -3, a 2, a -4, and a 4. So these are the coefficients that are corresponding to the x's. And then after that, you always pull down the first number, which is 1, and then you always multiply the bottom numbers with the number in the box. So 1 times 1 gives you 1. Then you add vertically. So negative 3 plus 1 gives you negative 2. Negative 2 times 1 gives you negative 2. So that's going to be 0 when you add. And then 0 times 1 gives you 0. So that's negative 4. Negative 4 times 1 gives you negative 4. So that's 0. So it looks like my remainder here, remember the first number here on the right side is always your remainder. Afterwards, it's your constant. Then just increases your x from there. So it looks like the highest one here is x to the third. So I have 1x to the third, negative 2x squared. Now notice how there's a 0 for x. That means the x here doesn't exist, or at least x to the first power you don't have to write since the coefficient is 0. It's just because when you multiply them, it just makes it disappear, so there's no need to write it. And then afterwards, your constant is negative 4. And same thing, you have a 0 for your remainder, so you don't have a remainder. So this is it. Okay, now that we've done a few synthetic divisions, let's try one of the simplifying problems in this page. So this is one of the simplifying problems. It's number 2. Oops. So this one's number 2, and you'll notice immediately there's a negative 1 as an exponent. So I know that I have to put AB in the denominator. So I'm going to start there and put AB in the denominator so that it can be a positive exponent now, a positive 1. And then the top, the polynomial does not have a negative exponent, so I'm going to put this on the top. And then afterwards, I'm going to try to divide each term by AB. Notice how this one, unlike synthetic division, only has one term. It does not have two terms, right? There's no plus and minus sign here. So that's the nice part. That means you get to split the expression up into 3 fractions. So I have a minus sign 6AB over AB, and then positive 5AB squared over AB. And so all you want to do is divide from here. So this is 3 over, it's really like a 1, so 3 divided by 1 is 3. A is squared here, A is to the first power, so if you divide, you subtract the exponent. So that's 2 minus 1, which is just 1 as a power. So that's just A. Write that better. That's weird. There we go. So that's just an A. And then the B's cancel, minus 6 over 1 is just 6. A's cancel, B cancel, since they're both the same exponent, so I just have a 6. And then 5 divided by 1 is just 5, and the A's cancel. B has a square on the top and just, 1 on the bottom, so 2 minus 1 is just B, right? B to the first power, so this is it. And so hopefully that helps you out with a little bit of the homework.